everyone. We're going to graph the polar equation. It's going to be an ellipse. We have r equals 1 divided by 3 minus 2 cosine of theta. The first thing we're going to do is test for symmetry. If it has cosine in it, it's probably going to pass this test and not these two tests. But let's do this very quickly. If for the first test, we're testing to see if it's symmetric to the polar axis, which is the x-axis. So you substitute in negative theta for your theta. We're doing that part. Since cosine is an even function, that turns to positive. So you get an equivalent equation given here. So this checks out, which we suspected. Now we are going to suspect that it doesn't pass this test. So let's see. For this test, this is a symmetry with respect to the line. Theta equals pi divided by 2, or the y-axis. So for this one, what you do is you take 3 minus 2 cosine of, and we're replacing theta with pi minus theta. Then we're going to use our difference formula for cosine and expand our equation. So this is going to be r equals 1 divided by 3 minus 2. And we're going to have cosine of pi, cosine of theta, plus sine of pi times sine of theta. All right. Now, sine of pi is 0. So this is just, the whole thing's going to be 0. This is negative 1. Sine of pi is negative 1. So you multiply two negatives, you get a positive. So we're going to get 1 divided by 3 plus 2 cosine of theta. These are not equivalent equations, so it fails. And then it's also not symmetric to the pole, but the test just says substitute your r by negative r. And clearly we don't get an equivalent equation. The only time you'd get an equivalent equation for this one is if you had an r squared for a lemon skate. All right, so let's, since we know that it's symmetric with respect to the polar axis, we want to graph the top part of from 0 to pi. And then we're going to use reflection over the x-axis to get the remaining values. All right, so we're going from 0 to pi. And filling this in, we're going to get 1. Pi divided by 6 is going to be 1 divided by 3 minus square root of 3. This is approximately 0.8. At pi divided by 3, we're going to get 1/2. At pi divided by 2, we're going to get 1/3. 2 pi divided by 3 is 1/4. 5 pi divided by 6 is 1 divided by 3 plus square root of 3, which is approximately 0.2. And at pi, you're going to get 1/5. So let's graph some of this. At 0, we're at 1. And I spread this out so we can see it better because it's a small graph. So this is going to be my 1. At pi divided by 6, we have 0.8. So that's kind of close to 1. So we'll put this at close to 1. At pi divided by 3, we're at 1/2. So since I went out 3, this will be right at here. At pi divided by 2, we're at 1/3. At 2 pi divided by 3, we're at 1/4. So let's see. Let's get it out a little bit. This would be 1/3, so a little less than that. And at 5 pi divided by 6, 2 pi divided by 3, we got 1/4. Well, that's good enough. 5 pi divided by 6 is going to be a little closer in here. That's good. And at pi, we're at 1/5. So get it closer in. So this is the top half of the ellipse. So the bottom half you just reflect it over, and we're looking at the 6's for the denominator, and just kind of do this, and there's your ellipse. You can match these points up, like pi divided by 3, match it up to 5 pi divided by 3, and kind of get an exact values there. So there we go. Thank you. Have a nice day. Bye-bye.